Okay, remember that a solution to an inequality will make our inequality true. Okay, and remember that we shade where it's true. All right, look at this example here. We have to determine whether each of these points is a solution to this inequality. So we have a couple of ways to do this. One of the big ones is that we can substitute the point in and see if it makes our inequality true. So here's our x, here's our y, there's the inequality. So we put in a 0 for the y and a 0 for the x. So is 0 less than negative 3 times 0 plus 4? Well, negative 3 times 0 is 0. 0 plus 4 is 4. So is 0 less than 4? Yes. So yes, it's a solution. Now, if you look at 0, 0 on my graph, you can see it's shaded. So I could have just eyeballed it. So just eyeballing it and looking at the graph, are the other 2 points solutions or not?
B and B, yes.
Okay, B is the point 3, 0. 3, 0 is here. Is that shaded?
No.
No.
C is.
Okay, 1, 1. Is that on a shaded boundary line? No. So neither of these points are shaded, so they are not solutions. Okay, that was Unit 4 review. Okay, so that was just one inequality. In Unit 8, remember that we're dealing with systems, so we're going to have more than one inequality. So, a system of inequalities is a set of inequalities with multiple unknowns. Now, in Algebra 1, our multiple unknowns is basically just going to be 2. But as you get higher up in math, you can start adding unknowns and adding more inequalities and equations. Okay, the solution to our system is a set of all the points that make both our inequalities true. Or if you had 3, it would make all 3 true, right? If you had 4, it would have to make all 4 inequalities true. To find solutions, we're looking for points that are shaded twice. So not only do they have to be shaded for one of our inequalities, but they have to be shaded true for both inequalities. All right, so let's look at this example down here. All right, so be very careful about what is your x and your y, because a lot of us are flopping coordinates around and getting our x and y confused. Remember that our first coordinate is our x, and x tells us to go right or left. The second coordinate is the y, and the y tells us to go up or down. Does that make sense to everybody? Don't get it backwards. All right, 0, 2.
No.
Correct, because do you see that it's only shaded one time? Okay, perfect. So that's a no. All right, what about the point 3, negative 5?
Yes.
Yes, it's shaded twice. Good. What about 4, 3?
No.
Correct. What about 3, 1?
Yes.
Yes, why?
Because it's on the shaded.
It's on 2 shaded boundaries, so it is shaded twice. Good. Okay, any questions about that one? Okay. Now this one has different shadings, same boundaries, but they're dashed this time. So remember, a dashed boundary shows us where the boundary is, but it's not solutions because it's not shaded. All right, what about 7, 0? 7, 0 is over here.
Yeah.
Yes.
No,
Okay, 0, 7 is not, but that's not the point we got. What about 3, negative 5?
no,
Correct. What about 6, 2?
no,
6, 2 is here. It's on a dashed boundary, so that's a no. What about 3, 1? Correct, because it's on 2 dashed boundaries, so it's double no. All right, last one. All right, this one I want you to shade with me, okay? Because this one's tricksy. So I have here a shaded boundary. And then do you see that for that one we are shaded below? Everybody see that?
yeah.
Okay. Then I have a dashed boundary. Boo, 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 boo. Okay, and that one is shaded above. Is that okay with everybody?
Yeah.
Okay. So look for the point 0, 4.
It's,
Do you see that it's on an orange boundary shaded and it's in the middle of the pink shaded area? So it's shaded twice. All right, what about the point 0, 0?
no,
It's in the orange area, but is it shaded pink? Because it's on the pink dashed boundary, right? So not 0, 0. What about 4, 0? Okay, this one's tricky because it's on a shaded boundary, but do you see that it's only orange? It's not pink, right? Okay, what about 3, 1?
no,
No, because it's on a dashed pink boundary. Everybody okay with that?
yeah.
Cool. Flip.
Yeah.
All right, so we can solve any systems of inequalities ourselves by graphing. And we will find the double shaded area. Watch out for your dashed boundary lines. All right. First inequality, yep. Look at your symbol. Is this boundary going to be shaded or dashed? Yes, it's shaded because it can be equal to, right? Okay. If you have a solid line in your inequality symbol, then you're going to have a solid shaded line, right? Okay. So this one has a b value of 4 and a slope of negative 1/2. So down 1, right 2, down 1, right 2, all the way across. And make it solid, shaded. Okay, before you graph your other boundary, you should do your shading. So you should do boundary, shading, boundary, shading. If you try to do boundary, boundary, and then do your shading at the same time, you're going to be confused. So remember, BS, don't do BBSS. BS. All right. Which way are we shading, above or below the boundary? If it's greater than? Above. So this is the way I want you to shade. I don't want you to shade dark. I just want you to lightly do little parallel lines parallel to your boundary line. Lightly. Okay. Now I'm going to graph my other boundary. Look at this symbol. Is this going to be shaded or dashed? Correct. Okay. Do you see that I'm not solved for y? I've got to get my y alone. So I'm going to subtract away the x from both sides, and I get y is less than negative x plus 2. So my b value is positive 2. and my slope is -1. Down one, right one, down one, right one. Oops. Don't forget to dash. Don't forget to dash, or you'll be in big trouble. Okay, look at the symbol. Am I going to shade above or below? Below. So again, we want lines very light, parallel to your boundary, but this time go under. Okay? And then the only place I want you to shade nice and dark is where your lines are cross-hatched in this little wedge up here. Everybody see where my little solution wedge is? Okay. Nice and dark. Now, we are not going to individually list solutions because we could be here our entire lives and still not be done with that list. That looks like a tiny little wedge, but as the plane goes, do you see that that wedge is going to get infinitely large? Yeah. Okay? So we could be here our entire lives and never finish listing our solutions. So we're just going to show them graphically, okay, not list them out. Cool?
Cool.
Okay. Let's do another one. All right, so this one, remember that when I have an x and a y in my inequality or equation, I will have a slanted line. But if I only have a y or an x, it's going to be horizontal or vertical. So remember, if I have y equals something, it's going to be like my horizontal asymptote for an exponential function. If I have x equals something, it will be like my axis of symmetry from my parabolas. Right? Unit 5, Unit 5. So I will have a vertical boundary line wherever x is 4. If you want to think about y, if you think about all of the points that are on this boundary, here's 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7, 4, 8. What do they all have in common?
0.
Their x is 4, right? That's why that's the boundary line for x equals 4. Was I correct to shade that boundary, or should I have dashed it? Good, shaded. Okay, now do I shade right or left? Correct. So I'm going to be shading above or to the right because it's greater than. Light parallel lines. Okay. Now I got to do my other boundary. All right, I want to subtract away my 2x. Be careful because this is a negative y. So I have negative y is less than my negative 2x plus 3. Do I want the opposite of y or do I just want y? Y. So how do I get rid of the negative 1 that's multiplying with my y? Divide by negative 1. And so I have to do it to both sides. Now all of my signs are going to go to their opposites. I'll get y, I'll get positive 2x, and negative 3. What else happens? My sign flips. I now have y is greater than. Now, in case you forgot, because it's been a long time, we all know that 8 is greater than negative 4, right? Okay, but if I divide both sides by a negative 2, okay, what happens is that 8 divided by negative 2 is negative 4. Negative 4 divided by negative 2 is positive 2. Now, which side is my big side? 2. So dividing or multiplying both sides of an inequality changes. What is in my shirt? Oh, it's my pocket. I have something in my pocket. Okay. It changes which side is the big side. Okay? Everybody happy with that? So the symbol has to flip so that the inequality is still true. All right, cool. So my y-intercept is 0, 3, and my slope is 2. So rise 2, run 1. What kind of boundary do I have? Dashed. Okay, look at your symbol. Are we shading above or below? Correct. So show me the cross hatching. Oops, that was kind of gross. Show me the cross hatching there as neat as you can. I'm really failing at this. Okay, so where are they overlapping? In this little infinitely big tiny wedge.
Looks like a cheese block.
Looks like a little cheese. Okay, any questions about that? Okay, cool. Guys, we're making good time. All right, now, this one is kind of like some really big thinking, okay? So the first thing I want to draw your attention to is that, do you see that we kind of have the same boundaries for each of the graphs? Okay, and if I look at this second boundary, do you see that my slope is positive 1/2, positive 1/2, positive 1/2? Everybody see that? So that's going to be this boundary, this boundary, this boundary, that boundary, right? Okay. The other one, if I rearrange it and get y alone, I will have y is greater than negative x plus 4. Y is greater than or equal to negative x plus 4. You see I have a negative slope for my first inequality? Y is less than or equal to negative x plus 4. And y is less than negative x plus 4. So that is this boundary, this boundary, this boundary, that boundary. Good? Okay, so look at your first graph. Okay, we have a dashed negative slope boundary, and we're shaded below. Here, let me shade. Okay, on my other one, I have a solid boundary line with a positive slope, and I'm shaded above. Okay, which one is that?
A.
A.
Okay, it's not A.
B.
All right, so let's just look at, can we just look at the dashed one for a second? So I've got a dashed boundary with a negative slope. Which two, A, B, C, or D, have a dashed boundary with a negative slope? A and D, yeah. Now, is it shaded above my dashed boundary or below? Below, so which one is that? It has to be less than for D, right? So this one is D. You almost had
Sorry,
it?
but somebody had said that like at the beginning right after we had stuff.
Huh?
Hello, good afternoon. Thank you for all who participated.
All right, the second one has a dashed negative slope, and it is shaded above. It's also got a solid positive slope. I got the hiccups, sorry. I just chugged all that tea and gave myself the hiccups. And that one is shaded below. Okay, which one is that?
A.
A, correct. Oops. All right, can you guys match up the last two?
Yeah.
Go. Bless you.
Be crazy if I was B. I literally had so many going all of them. You know what?
Okay, do you see that the third one is shaded under both? So it's like less than and less than? Okay, which one's that? C, you are correct. And the last but not least is B.
I knew that because I can throw one.
All right, any questions? Okay.